So we're going to start our pumpkin project. And one of the things is you need to really be fluent in graphing inequalities. So let's say Mrs. Rose wanted to make a triangular nose. Well, when Mrs. Rose uses the dotted lines, that is going to be the parent function. So the base of a triangle, or the very start of the triangle, of course, would be two lines or two rays that are off of the same vertex point. And so that would be the parent function. But in my little pea head, I'm thinking, you know what? I really would like it to face down. So let's see. The parent function looks like this. But I want this to, oops, sorry. I want this to face down. So I want it to reflect. So I kind of think that this would be kind of cool. And so far that would be kind of good. Yeah, but maybe I want it up a little bit. Maybe I want it to be about right here. But you know what? I really want it to be skinny too. I really don't want it to be as wide. I don't want as big and wide as a nose like that. So I just want to shift it up a little bit. And I want to make it skinny like this, and I want to stop it right here. So let me see what I did. I negated it, so that made it reflect. I shifted it up, 1, 2, 3, 4. Well, that means I changed the K. I didn't shift it horizontally, but I did make it skinnier. So that means I made it stretch towards the y-axis. And instead of going over 1 and up 1, I went over 1 and down 2. So I multiplied by a -2. So my new nose looks like this. Okay, but Mrs. Rose, that means I have a lot of questions to answer. So let me see if I can answer the questions that I might need to answer for my pumpkin project. Let's see. I reflected over the x-axis. I have a vertical stretch with a scale factor of 2. I have a vertical shift up 4. I changed my domain. My domain runs from -1 to +1, and my range now has changed. My range goes from 2 to 4. Let's see, what else do I know? Oh, I have an increase interval, and that increase interval goes from, need to put a bracket there, from -1 to 0, and I have a decrease that goes from 0 to +1. End behaviors. End behaviors. Now, end behaviors, Mrs. Rose says she just wants them according to the function itself. So as x is approaching -infinity, y is approaching -infinity, and as x is approaching +infinity, y is approaching -infinity, right? Oh, okay. And of course, this is not 1-to-1. I think that might be all the questions I had to answer. But you know what? My nose isn't finished yet. My nose isn't finished yet because I got to complete that. I got to complete that. It just is driving me crazy looking at it like that. I think what I want to do to complete it is I just want to connect those dots. I just want to connect those dots. So I'm going to go ahead and connect those dots right there. So the first thing I need to do is I need to label this as function number 1, and then I'm going to label this one as function number 2. Well, function number 2, the parent function, is a line because this is linear, but my equation is just y, or f of x, is equal to 2. Okay? It is a constant interval. It doesn't increase or decrease. Okay? I didn't reflex it over the x, but I did a horizontal stretch with a scale factor of 0. This is the only time that you can say that there's a scale factor of 0 because of the linear being a horizontal. I do have a vertical shift up. My domain for this one runs from -1 to 1. And my range at this point is just a 2. It's just a 2. Okay? My end behaviors for this one, well, as x approaches -infinity, y equals 2. As x approaches positive infinity, y equals 2. It doesn't approach 2 because it is 2. And of course, it's not 1 to 1. How you doing so far? Now, you can kind of get the idea of if you want to use a triangle, okay? Just remember that a lot of times it'll depend on if you are doing the reflection. Maybe you want to do several triangles for teeth. If you do several triangles for teeth, remember that each one of these is separate, but you only have to do one of the functions. Remember, you have to have one absolute value function, and you have to have one linear equation. So a lot of them can change. All right, let's look at something else. What if I wanted to use a quadratic? Well, if I wanted to use a quadratic, maybe what I wanted to do is I wanted to do an eyeball. Okay, so I'm going to think for just a minute of the parent function. The parent function looks like this, and then it goes over 2 and 1, 2, 3, 4, up 4, and it goes over 2 and up 4. So the parent function kind of looks like this. But you know what? I don't want mine to be there. I want mine to be up over here. And I want it to kind of look like this. Well, that's the regular parent function, except I've made a couple of changes to it. Okay, let's see what kind of changes Mrs. Rose has made to that. Well, the first thing that she did was she definitely reflected it over the y-axis. Okay, so Mrs. Rose definitely did the reflection. Okay, she reflected it over the y, but then she moved it too. She moved it 1, 2, 3, 4, 5. She moved it over 5. So, but I moved it to the positive, but when I do the x, I always make it look like it's the opposite. And then that's squared. And then I also went ahead and moved it up. 1, 2, 3, 4, 5, 6, 7, 8. Oh, so my k value changed to +8. Oh, that's what it looks like. I didn't change a except to do reflection. I like the shape of that, so I'm okay with that. So my parent function is f of x is equal to x squared. I reflected over the x-axis. I did a horizontal shift five right. I did a vertical shift up 8. I stopped my domain. I started it at 3 and I ended it at 4, 5, 6, 7. My range starts at 1, 2, 3, 4 and ends at 5, 6, 7, 8. Okay. I have an interval of increase, and mine is increasing from 3 to 5, but then it decreases from 5 to 7. Okay. My end behaviors, as x approaches negative infinity, so does y. And as x approaches positive infinity, y approaches negative infinity. Now, one thing I forgot to mention is this does have line, this does have line symmetry, but it is neither. It is not odd, it is not even, because it does not reflect over the y and it does not rotate around the origin. Okay? All right. Well, what else do I need to know? Looks pretty good to me, Mrs. Rose. Now, of course, remember, it's not perfect because it's on the smartboard, but I do expect yours to be perfect. Now, what if Mrs. Rose just wanted to do this? Let me just go ahead and copy this. And in fact, let's just go ahead and clone it. And what if Mrs. Rose just wanted to move it over 1, 2, 3? Okay, well, guess what, guys? As long as I mark this one right here as the number 3 function that I want graded, this is just an extra function. I don't have to have that one graded. Okay? What if I wanted to make a chin? What if I wanted to make a chin? Well, if I start here, instead of going over 1 and up 1 and over 2 and up 4, maybe I could go over 1, 2, 3, 4, 5 and up 1 and go over 1, 2, 3, 4, 5 and up 1. And let's say I just stop it like that. Okay? Well, basically what I've just done is I've taken that parent function and I've multiplied everything, correct? I did, okay? And it is by how much? Do you know? Do you know? I'm not really sure. I hope that you know. If I have this 5 and this goes up 1, what did you do? Stay tuned and we'll talk about it in class tomorrow. Toodles!